Hello, welcome to my presentation regarding value engineering. Today, in this video, I'll be explaining about value engineering on the 25th Avenue and Union Pacific Railway grade separation in Illinois. So let's proceed. So first off, we'll have to discuss what is value engineering first. First and foremost, value engineering is defined as the systematic analysis that aims to improve a project whilst also reducing costs. This also includes ideas and recommendations regarding value engineering are gained through project analysis, which is typically done during the construction process or the design process. So let's continue. A bit of background regarding the project that we are about to analyze. The CREATE, or Chicago Region Environmental and Transportation Efficiency Program, is a federal program made in collaboration with the government and the regional government of Illinois and the city of Chicago in order to improve the effectiveness of all modes of rail transportation and reduction of traffic delay. Okay, now we're talking about the location and project context. So two locations. 25th Avenue is a four-lane urban arterial roadway under the jurisdiction of the village of Bellwood. It is a significant stretch of roadway as it directly connects to Interstate I-290, an important auxiliary highway within Chicago. As you can see, the red arrow points to 25th Avenue. Then we have the green arrow. Union Pacific operates a four-track railroad with an at-grade crossing on 25th Avenue. These tracks act for freight movement and access to the train stockyard. And the green arrow, as you can see, points to the four-track railroad present. The issue that the CREATE program previously mentioned aims to rectify is to turn these crossings into a grade separated crossing. Currently, it is an at-grade crossing. So we'll talk about the project constraints and risks. Identification of constraints is part of the course during a value engineering study. Throughout the value engineering study, the team identifies some potential risks in a project that can cause problems during construction, inflated costs, and affect performance. So on the right, as you can see, there are some identified constraints within the project. Firstly, the impacts toward existing or planned rail facilities, site constraints, scheduling, land acquisition, etc., etc. So this is the table that illustrates the project risk assessment hierarchy. The higher the rank, for example, 5, the higher the priority and the higher the risk. The lower it is, the less of a risk it poses towards the project. Okay, let's talk about the stakeholders. The project positions or stakeholders define those that hold particular interests or importance within the project. We have three definitions: the user, owner, and the stakeholder. A user is defined as one who physically uses and maintains the project. The owner is the one responsible for financing the project, managing it, and represents their interest. The last one is stakeholder. Those that financially affect the project itself, changes towards behavior, and/or changes towards the environment. Okay, let's proceed. Needs and desires. During the study, the team must identify the project expectations. These can be differentiated into two different types. Needs, signified with an N, and desires, signified with a D. Needs is defined as the function that must be fulfilled and are imposed by all positions. Desires are defined as the function that is not necessarily required, however should be fulfilled if cost is neither a factor or violates constraints. As you can see in the table on the right, it shows which are considered needs, which are considered desires. So we have the cost estimation and analysis. Cost estimates and cost analysis are also done by the value engineering team and compares two sets of data: preliminary design review, PDR cost, and revised PDR, which reflects the actual value. Cost analysis is most beneficial on projects that contain a great number of different design components that have been identified and estimated. You can see the table on the right, the value engineering study cost analysis. Let's continue. The function analysis. The function analysis is an analysis conducted by the team in order to better understand and analyze the functions of individual components within a project. These can be defined in three different ways: verb, noun, and classification. Verb defines the activity/purpose of the component. Noun defines the object that the verb must accommodate/carry out. Classification is defined as the functional hierarchy of the verb within the component. So this is the complete overview of the components as well as the functions. Apologies. Idea evaluation. After the value engineering team have completed their study, the process heads towards the evaluation phase, where each item, or idea in this case, individually are discussed regarding the potential performance and cost merits of the proposed changes. Each idea is rated based on their analyzed potential for the betterment of the project. The rating measures two factors: performance and costs, with each providing a rating from 1 to 5. As stated previously in the summary, the ideas that provide increased performance and/or reduction in cost yield greater ranking, which means a higher likelihood of being implemented within the project. So this is the complete overview of every single idea presented in this value engineering project. We start from the land acquisition schedule, development of accelerated land acquisition process, to review stormwater drainage and detention design. As you can see, these are ranked pretty highly. Some have performance grades of 5, which means excellence, and then those that have costs equal to 3, which are the same as the current process. So it's neither a positive nor a negative. However, the performance is a positive because it ranks higher than 3, so it's not equal. You can see STR number 4, which ranks both in performance and cost 3. If it is tied to current issues, to the current design or proposal, then it is to be reconsidered. Will it be applied, or will it be scrapped? Or might it be re-evaluated? So this is the final slide. In summary, there are 16 recommendations and 6 suggestions provided by the value engineering team, calculated with an estimated cost saving of up to $1.71 million if all goes according to plan. Alright, I think that concludes my presentation on the value engineering on 25th Avenue and the Union Railway in Illinois. Thank you very much. Have a great day.